Somewhere beyond the clouds of Saturn, past the rings of ice and dust that have dazzled astronomers for centuries, lies a world so strange, so alien, and yet so hauntingly familiar that scientists have spent decades dreaming of the day they could send something there to touch its surface. That world is Titan, Saturn's largest moon, a place shrouded in thick orange haze, where rivers of liquid methane carve valleys into the ground, where nitrogen winds howl across plains of organic sand, and where the chemistry of life, in some frozen primordial form, may be waiting silently beneath the surface. For years, humanity could only watch from afar, but that is about to change. NASA has now officially begun building Dragonfly, a nuclear-powered eight-rotor flying machine unlike anything ever launched into space, and with it, humanity is preparing to take its boldest leap yet into the outer solar system. The announcement that construction has formally begun on Dragonfly marks one of the most significant milestones in planetary exploration in recent memory. Engineers at the Johns Hopkins Applied Physics Laboratory, one of NASA's premier research facilities, are already deep at work integrating the spacecraft's brain and its power source, the beating heart of a machine designed to fly through an atmosphere it has never touched, on a moon it is only seen in photographs. This is not a rover. This is not a lander that sits in one place and scoops up nearby soil. Dragonfly is a drone, a real flying drone, and it will hop from location to location across Titan's surface like a scientific explorer on wings, covering distances in a single flight that a rover could not traverse in years. To understand why Titan was chosen, you have to understand what makes it so extraordinary. Of all the moons in our solar system, Titan is the only one with a dense, substantial atmosphere. That atmosphere is composed primarily of nitrogen, just like Earth's, but it is also laced with methane and a rich soup of organic molecules that rain down from the sky and accumulate on the surface in thick hydrocarbon dunes. The atmospheric pressure at Titan's surface is about 1.5 times that of Earth at sea level. The gravity is weaker, only about 1/7 of what we feel here. Together, these conditions create something remarkable for a flying vehicle. Lift is significantly easier to generate on Titan than it would be on Mars or even on Earth. Despite temperatures hovering around -179 degrees Celsius, despite the crushing distance from the sun, Titan's thick air is, in a counterintuitive way, a gift to aeronautical engineers. Dragonfly will exploit this gift fully. The spacecraft is roughly the size of a car, a substantial machine by any measure, and it is equipped with 8 rotors arranged in 4 pairs, which is why it has earned the affectionate nickname Octocopter in certain corners of the scientific community. Those rotors will spin through Titan's dense atmosphere and lift the entire vehicle off the ground, allowing it to travel dozens of kilometers between landing sites during each flight. While NASA's Ingenuity helicopter on Mars was the size of a tissue box and performed short, cautious hops to prove a concept, Dragonfly is a fully operational scientific platform built not just to fly, but to work, to measure, sample, analyze, and transmit data that will reshape our understanding of chemistry, planetary science, and the origins of life. The power source that makes all of this possible is the multi-mission radioactive thermoelectric generator, or MMRTG. Sunlight at Titan is too faint and too filtered through the thick haze to be useful for solar panels. Instead, Dragonfly will draw its power from the heat of radioactive decay, the same technology that has powered the Voyager probes, the Curiosity rover, and the New Horizons mission to Pluto. The MMRTG will continuously generate electricity from the natural decay of plutonium-238, allowing Dragonfly to recharge its batteries during long periods of rest on the surface, then launch again when it is ready for its next leg of exploration. This power system makes Dragonfly almost entirely self-sufficient in an environment where no resupply mission will ever come. The journey to Titan begins on Earth, and it begins in 2028. That is the year Dragonfly is scheduled to launch aboard the SpaceX Falcon Heavy, one of the most powerful operational rockets in the world today. The Falcon Heavy will hurl the spacecraft out of Earth's gravity well and send it on a 6-year cruise through the solar system. 6 years. For 6 long years, Dragonfly will drift through interplanetary space, crossing the orbit of Mars, threading past the asteroid belt, and finally falling under the gravitational pull of Saturn. It will arrive at Titan in 2034, where it will perform a precise atmospheric entry and descent, eventually settling onto the Moon's surface in a region near the equator known as the Selk Crater. Selk Crater is not a random choice. Scientists selected it with great deliberation because it represents one of the most scientifically compelling environments on Titan. The crater was formed long ago by an asteroid impact, an event violent enough to melt the water ice in Titan's subsurface and temporarily mix it with the organic compounds that blanket the surface. For a brief window of time after that impact, liquid water would have existed at the impact site, interacting with organic molecules in a chemical reaction that mirrors some of the most important processes in early Earth history. The result was a cocktail of prebiotic chemistry, the building blocks of life, that has since been preserved in frozen form. When Dragonfly lands near Selk, it will be landing in what amounts to a natural laboratory for the study of life's origins. From its initial landing site, Dragonfly will begin an extraordinary journey across the face of Titan. Its flight plan calls for it to make dozens of flights over a period of years, hopping from site to site across the Moon's surface and covering distances in a single flight that a rover could not traverse in years. Each landing site will be a new opportunity for scientific investigation. The spacecraft is equipped with a suite of instruments specifically designed for this environment: cameras to document the landscape in vivid detail, mass spectrometers to analyze the chemical composition of surface samples and atmospheric gases, seismometers to probe the interior of the Moon, and meteorological sensors to study Titan's weather patterns and atmospheric dynamics. Every instrument aboard Dragonfly has a role to play in piecing together the story of a world that has been evolving chemically for 4.5 billion years. One of the most critical capabilities Dragonfly possesses is its ability to drill into the surface and collect samples for in-situ analysis. Rather than simply observing from above, the spacecraft will physically interact with Titan's surface, scooping up material and running it through its onboard laboratory. The results of these analyses will be transmitted back to Earth, where scientists will pore over the data with the same excitement that greeted the first images from Mars. But there is one enormous technical challenge that no amount of engineering can fully overcome: the communication delay. At Titan's distance from Earth, radio signals take roughly 1 hour to travel each way, meaning that every command sent to Dragonfly and every response received from it will be separated by about 2 hours of waiting. This is why Dragonfly has been designed to operate with a high degree of autonomy. It must be capable of making decisions on its own, navigating hazards, and conducting science without moment-to-moment guidance from mission controllers on Earth. This is the story of one of the most ambitious robotic missions in history, a flying laboratory launched across the solar system to answer questions that have haunted science for generations. Does the chemistry of life arise naturally in environments rich in organic molecules and liquid solvents? Is Titan a frozen snapshot of early Earth, waiting to tell us something profound about our own origins? And in the vast, silent plains beneath that orange haze, is there something more, something unexpected, something that rewrites the story of what life is and where it can exist? Dragonfly may not answer all of these questions, but it will fly further, see more, and reach deeper than any mission before it into the heart of an alien world. The rotors are being built, the nuclear core is being prepared. The countdown to one of humanity's greatest adventures has quietly and magnificently begun. If this video sparked your curiosity and filled you with the same sense of wonder that drives explorers to look beyond the horizon, please take a moment right now to like this video. It genuinely helps more people discover content like this. Share it with a friend who loves space, science, or simply the idea that humanity is still reaching for the stars. Drop your thoughts in the comments below. We read every single one, and we would love to know what excites you most about the Dragonfly mission. And if you haven't subscribed to this channel yet, please do it now and hit the notification bell so you never miss another journey into the cosmos. The universe is waiting, and so are we.